Hello, Assalamu alaikum. My name is Hamza Rahman, and I'm a student of Air University doing mechatronics engineering. This is my fourth semester, and my course is microcontroller and embedded system. So today, the topic is Introduction to Computers, Chapter 0, and the book is the AVR microcontrollers and embedded systems using assembly and C. So let's start. Today, the topics are internal organization of computers. The computer consists of different parts, as you know, it consists of memory, CPU, that is central processing unit, and input output devices. Uh, these parts are connected together to form a computer. These are connecting of connecting memory of CPU and connecting of input outputs devices to the CPU. Internal organization of a computer. It consists of CPU, memory, input output devices. Input devices consist of keyboard, mouse, sensors, or anything that takes input. Like sensors could be a heat sensor, IR sensor, and output can be LCD, monitor, a printer, or a robotic hand. Memory, everything that can store, retain, and recall information is called a memory. A memory can be the types of memory can be hard disk, a piece of paper, uh, RAMs, ROMs, read-only memory. RAMs are random access memory, floppy disks. These all consist of memory. Memory characteristics, capacity. The number of bits that a memory can store. Example: 128 kilobytes to 56 mega. 128 kilobits to 56 megabits. It can be of contained of bytes, as 8 bits is equals to 1 byte. So a byte is a bigger unit of memory than bits, and in your memory you see the hard disk is of approximately 256 or 500 gigabytes. That means 256 into 10 raised to power giga is 10 raised to power 9, and then bytes. To convert bytes into bits, you divide it by 8. Means 8 means 1 byte is equals to 8 bit. Organization, how the locations are organized in RAM or in a memory. uh, 128 into 4 memory has 128 locations, bits each. Like 128 into 4 memory contains 128 locations, and 4 the 4 is the size, that is of 4 bits, and 128 are like the rows, number of rows. Access time, how long it takes to get data from the memory. This depends on the speed of the memory. Memory consists of two types: semiconductors, non-semiconductors. These are floppy disks and hard drive. These both are non-volatile memories. They store the data permanently, but on the other hand, RAM is a volatile memory. It stores data temporarily until the data is running. If it is not running, then the RAM cannot store the data. Semiconductor memories. ROM, mask ROM, PROM, EPROM, erasable PROM. PROM stands for programmable ROM, and ROM stands for random read-only memory, and Flash EROM, And then comes RAM. RAM stands for random access memory, and DRAM, dynamic memory, SRAM, static memory, and NVRAM, non-volatile. Programmed by IC manufacturers, mask ROM, PROM, programmable ROM, OTP, one-time programmable. You can program it only once. EROM, erasable programmable memory ROM. UV EROM, you can shine ultraviolet radiation to erase it if you want to extract or erase an information from this type of ROM. You need to shine it with ultraviolet radiations. Uh, Erasing takes up to 20 minutes. The entire content of ROM is erased. This is the pinout of this type of ROM. Uh, EEPROM, electrically erasable programmable ROM, erased instantly. Each byte can be erased separately. That was a next gen version of the previous ROM. Erased in a flash ROM. The entire device is erased at once. In this table, you can see the speed, the pins, the VPP, the voltages, and the capacity, the part number, the manufacturer's part number. Semiconductor memories, SRAM, static RAM. This is made up of flip-flops, and flip-flops are made up of latches and sorry, not latches, transistors. From transistors, the gates are made, and from the different gates and not or XOR nor you can make different latches, and by modifying some latches you can make flip-flops, and from flip-flops you further from flip-flops and latches you can make further registers, and from registers you make RAM. These are the step-by-step processes for the construction of RAM. RAM is a larger memory unit, and as you go step by step behind, like behind you get the basics. These are made of flip flops. Advantages: these are faster, no need for refreshing. Disadvantages: higher power consumptions, expensive. This is a 2K into 8 RAM, a pinout diagram. DRAM, dynamic memory. These are made up of capacitors. Capacitors stores the data, like when the capacitor is charged, and from by the charging and discharging of the capacitors, the dynamic memory works like this. The capacitors are the basic, the most fundamental component of the dynamic RAM. Advantages: less power consumption, cheaper, high capacity, slower, and refresh needed. These are the disadvantages. NVRAM, non-volatile RAM. It is made up of SRAM, battery control circuitry. Advantages: very fast, infinite program, erase cycle, non-volatile. Disadvantages: expensive. Internal parts of computer: CPU. Task: it should execute instructions, it should recall the instruction one after another and execute them. A CPU is a central processing unit, it is the brain of the whole computer. It carries out the different functions that we made from the CPU can carry out different functions. Uh, our CPU can be seen in most desktops, mobile phones, and CPUs are also present in ACs and microwaves because we program it, we make logic design for some specific purpose that the CPU carries out. Connecting memory to CPU, memory pinout. These are the memory pinouts of the CPU. Reading from memory. It is a graph that means how to read from a memory. The memory can execute two type of functions. First is reading a memory, and second is writing or editing a memory. So when we are reading from the memory, when the address is provided, that the TRC is the time in which the address is provided, or is in which the address is valid, and the data valid, the TA is the time or the delay after the data is valid to us. Connecting input output devices to the CPU. CPU should have lots of pins because it is connected to the network. The input output devices, mouse, keyboard, sound card, graphics card, and all that. The monitor, the printers, the robotic hand, and sensors, these are all connected to the CPU. The CPU is connected to the input output devices like this. These are the address bus, the data bus, the control bus that executes the read and write functions. Connecting input outputs and memory to CPU using bus memory mapped input output devices. How could we make the logic circuit address bus? The logic circuit enables CS when address is between 0 and 15. Solution. This is the question, and the solution is write the address range in binary. Second step is separate the fixed part of address. Third is using a NAND, design a logic circuit whose output activates when the fixed address is given to it. From address 0 to address 15, the 0 terms are a single one and the other are a single one. These work like the gate and gate, in which when both the inputs are 1, the output is 1 unless the output is 0. So it, there is a decimal to binary conversion. You can see these are the simple conversions: hexadecimal, decimal to hexadecimal conversion, hexadecimal to decimal conversion, binary addition. This is the ASCII table in which every different ASCII stands for American Standard Code for Information Interchange. The different signs and the different alphabets, when you press A, capital A, or the at the rate onto our keyboard, these are the signals. These are the binary codes that uh, are sent to the CPU by the address bus, and then the CPU shows that information on our output device, that is the monitor, and or perform some other function that the binary information carries out. So every every different sign, or every different alphabet have their unique binary code. Address decoder. Design an address decoder for address of 300H to 3FFH. This is a solution. Write the address range in binary. Separate the fixed part of the address. These are the fixed part. Design the logic circuit, and from these fixed part we design the logic circuit. So that's all for today. Uh, Thanks for watching. Allah Hafiz.